My dear students, today I am going to discuss physics of class 9 from the chapter of motion. Now, from this chapter, one student sent me one question by my WhatsApp number. So, Anirban Bora of Jorhat sent me this question. If action and reaction are equal and opposite, why do not they cancel each other? This is the question, you see. If action and reaction are equal and opposite, why do not they cancel each other? So this was sent to me by Anirban Bora of Jorhat. Okay, to answer this question, see this example. Now consider this is the floor on which a box is lying. So this is a box lying on the floor. Now one person is pushing it towards east. This is east, this is west. Another person is pushing the same box towards west. So one person is pushing the box towards east by applying 100 Newton of force. We consider it to be positive. Force towards east, suppose we take as positive. Then another person is pushing the box towards west, which will be negative, by applying the same 100 Newton of force. 100 Newton of force, but this one we take to be negative. So by negative we mean towards west, and by positive we mean towards east. So these two equal and opposite forces, plus 100 Newton, minus 100 Newton. This is acting towards east and this is acting towards west. So these two equal and opposite forces are acting on the same object box, and so they will cancel each other. So plus 100 minus 100 together will be 0. Together the force will be 0. Net force or resultant force will be 0. Now these two equal and opposite forces are cancelling each other. Plus 100 minus 100 together 0. So resultant force is 0 because the two forces are cancelling each other. Now they are able to cancel each other because they are acting on the same object box. So you see, if two equal and opposite forces act on the same object, only one object, then they will cancel each other and the resultant or net force will be 0. Similarly, in the example of, say, in the game of tug of war, what happens? The rope is the object. Suppose this is a rope. In the game of tug of war, a rope is pulled by two opponent parties by applying forces. Suppose one party is pulling it towards east by applying, suppose, 50 Newton of force, and another party is pulling it towards west, which is negative, so by applying the same 50 Newton of force. So this is the rope. So here the object is rope. So on this same object rope, two equal and opposite forces are being applied. One towards east, plus 50 Newton, and the other towards west, minus 50 Newton. These two equal and opposite forces are acting on the rope, acting on the same object rope, and therefore they will cancel each other. So when two equal and opposite forces act on the same object, so here the same object rope, here the same object box. So when they act on the same object, a single object, then they cancel each other and the resultant force becomes 0. They have cancelled each other. Alright. So remember, two equal and opposite forces must act on the same object, only one object, so that they can cancel each other. Now this does not happen in case of action-reaction. In case of action-reaction, the two equal and opposite forces act on two different bodies. For example, in the situation of that bullet fired from a gun. Suppose this rectangle indicates a gun. So this is a gun from where a bullet is fired in this direction. So here there are two objects, gun and bullet. Now gun is applying a force of action on the bullet. Suppose that action is, we call it plus 80 Newton. The gun is exerting a force of 80 Newton on the bullet, and this force, suppose we call positive, plus. So that is action. And what is the reaction? Reaction is equal and opposite, 80 Newton, but this is minus. So this 80 Newton of equal and opposite force is being applied by the bullet on the gun. So action is by the gun on the bullet, that is plus 80 Newton. And the reaction is by the bullet on the gun, which is minus 80 Newton. You followed? Now these two are equal and opposite, no doubt. Equal, 80 Newton, opposite, one is plus, other is minus. So action is in this direction towards west, and reaction is on the gun towards east. Alright, so equal and opposite. But they are acting on two different bodies. Therefore, they cannot cancel each other. They cannot cancel each other. In the previous two cases, those two equal and opposite forces cancel each other. So resultant or net force was 0, and that is why that box could not move, the rope could not move. The box remained at rest, the rope remained at rest. But here, the action and reaction do not cancel each other because they are acting on two different bodies. So two bodies are involved and they are free to move. Therefore, the bullet moves forward and the gun recoils backward. So both are moving. You followed? So in this case, the action reaction results in motion. But in the previous case, since they cancel each other, the two opposite forces do not cause any motion. So in the previous cases, we cannot call them action reaction. Simply we call them what? Equal and opposite forces. But in this situation, we call the two forces action and reaction. Okay. So what will be the answer then to this question? So action and reaction are equal and opposite, but they do not cancel each other because they do not act on the same body. They act on two different bodies. And that is what we say mutual. So action and reaction are mutual. That means two objects are mutually acting on each other. Okay. All right. So now the second question, another question which is being sent to me by one girl student from Tinsukia, Tandrali Sharma. One Tandrali Sharma sent me this question from Tinsukia. So the question is this: why the unit of time appears twice in the unit of acceleration? Why the unit of time appears twice in the unit of acceleration? To answer this question, we have to see the formula of acceleration. So acceleration is what? Rate of change of velocity. Rate of change of velocity, that is the definition. So the formula is this: change of velocity divided by time. This is the formula for acceleration. Change of velocity of an object divided by time in which that change of velocity has taken place. All right. Therefore, the numerator will be unit of velocity. Unit of velocity. If we want to write the unit, if we want to write the unit of change of velocity, we will write the unit of velocity. And here, denominator is unit of time. Unit of time. So change of velocity, the unit will be unit of velocity, and time, unit of time. Now what is unit of velocity? If we consider SI unit, unit of velocity is what? Meter by second square. Unit of velocity, meter per second. Meter per second. That means meter per second. All right. Meter by second. Unit of velocity is what? Meter by second. Divided by unit of time. Unit of time. Unit of time is what? Second. See, unit of velocity is what? ms minus 1. That means m by s. M by s. All right. And unit of time is what? Second s. All right. We are considering SI unit. We are considering SI unit. So isn't it m by s square? So meter per second square. So you see second appears twice. So this is why in the unit of acceleration, in the unit of acceleration, the unit of time appears twice. Now in order to explain this, explain the answer, you have to start like this. You have to write the formula, then you show by taking SI unit. So unit of velocity is meter by second divided by unit of time second. So it becomes meter per second. So this we write what? ms minus 2. The SI unit of acceleration is meter per second square. So the second is appearing twice. So unit of time appears twice. Okay, this is the answer. Okay, now we go to the third question sent to me by another student. So you are allowed to, I told you before, my WhatsApp number also I gave. So you send me queries, feedback, etc. in this WhatsApp number. Okay, so this is the number. (84867683835). Okay. All right. Now third question. This. So I selected the question which are related to the same chapter. So other questions I'll see in course of time. I'll select. Okay. Now the third question from this chapter was sent by one Kamal Kumar of Tura, Meghalaya Tura, one Kamal Kumar. So he gave this question. Actually, he sent me a numerical problem. Okay, the problem is this. An object is thrown vertically upward with a velocity of 25 meters per second. At the same time, another object is dropped from a height of 100 meters. When and where will they meet? Okay. Now, similar type of question is there in your exercise in class 9 CBSE science book. In the exercise, there is a similar question. I'm not sure about the figures. Okay, I repeat the question. An object is thrown vertically upward with a velocity of 25 meters per second. At the same time, another object is dropped from a height of 100 meters. Now the question is when and where will they meet? One object going up, another object coming down. So they will meet somewhere. Where and after what time? That is the question. All right. Now we suppose, so let them meet after t seconds. So after t seconds of the first body going up and after t seconds of the second body coming down, they are being sent up and thrown and dropped from height of this. So at the same time, so let them meet after t seconds, and let them meet at a height of suppose at a height of h meter from the ground. When you say height, it is always from the ground. Height means from the ground, isn't it? So from ground h meter above they meet, and after what time? T seconds they meet. Okay. Now there are two variables, so we can form two equations and solve. Okay. Now considering the first body, let us consider the first body which is being thrown upward. All right. Now what distance it will cover? Now the first body is going up to a height of h, so the distance covered is h. Now the distance formula, s equal to ut plus half at square, that formula, isn't it? Now this body is going up. All right. So this is this is ground, this is 100 meters. So the first body is going up and they meet here. This is h. This is ground level. This is the top 100 meters from which the second body is dropped. Now first body is going up, second body is coming down, and they meet here. At a height of h from the ground, and this distance will be then 100 minus x, 100 minus h. If this is h, the whole thing 100, then what will be this part? This part will be what? 100 minus h, isn't it? So that is how you can draw a diagram. Okay, now this h is equal to that, using that formula, ut minus half gt square. Yes, now for this question g is given, that acceleration due to gravity is given 10 meter per second square. For this question, value of acceleration due to gravity is given 10 meter per second square. Right? Now this formula h equal to ut plus half at square. Now since the body is going up, it will be minus retardation. So h equal to ut minus half gt square. All right. Now h is that h equal to, so we get h equal to u. Now u is what? Question given 25. So 25 t minus half g is given 10 into t square. All right. So h equal to 25 t minus 5t square. So suppose this is equation 1. Since there are two variables t and h, we have to form two equations. So we got the first equation, h equal to ut minus half gt square. Then putting the value u 25, z 10, we get 25t minus 5t square. This is equation 1. Okay. Now let us see the second equation. Now this is for the first body. So this we got considering the first body. Now consider the second body, which is coming down. Now coming down, it has covered this distance after time t. What distance? 100 minus h. So again that formula s equal to ut plus half at square, that equation of motion. So 100 minus h. This distance the second body has covered. So h distance equal to what? Ut. Now here u is 0. So it will be ut plus half gt square. Okay. Now let us put the value. Here u is 0 into t. Because when you drop something from a height, so the initial velocity is 0. Okay. So initial velocity is 0. So 0 into t plus. Why plus? It is acceleration coming down. When going up, it is minus retardation, and while coming down, it is acceleration. So ut then plus half z, half into z is 10 t square. So what you get? 0 t 0. This is gone. So half, this is 5t square. So 5t square is equal to what? 100 minus h. This is the second equation. So we have got the two equations. Now only question of solving. So how will you solve? Simply there are different ways of solving the two equations. These are the two equations. So the second equation I write here. First equation I write here. H equal to 25t minus 5t square. It was 5t square, isn't it? Minus 5t square. Okay. So this was the first equation. This is the second equation. Now you can solve by any method. There are different methods: substitution, elimination, addition, subtraction. So I do by elimination, addition, subtraction. That is how I solve. So I add. So when you add, this minus 8 plus 8 cancel, what remains? 100 equal to plus 5t square minus 5t square cancel, what remains? 25t. So 25t equal to 100, therefore t equal to 100 by 25, 4 seconds. This is the time answer. So we got one answer. So we solve how? By adding. Minus 6 plus 6 cancel, plus this minus this cancel, 25t equal to 100. So t equal to 100 by 25, 4 seconds. So after what time they meet? 4 seconds. So this first body comes here, second body comes here after t seconds, so they meet. Now at what height? So now let us find the value of h. Okay. This is the second variable h. So let us find the answer h. Now from the first equation, you see what is h equal to. From the first equation, what is h equal to? 25t minus 5t square. We use the first equation to find the value of t, isn't it? Okay. To find the value of h, because t already we got. So h equal to 25 t. Now t is 4, we have found out, minus 5 into t, 4 square, t is 4. That means 25 into 400 minus 5 into 16, 80, isn't it? So what you get? 100 minus 80, that is 20. So 20 and height, so it will be meter. This is the height, second answer. So finally we got the answer. What answer? They meet after, what is the answer? They meet after t seconds, 4 seconds. And they meet at what height? At a height of 20 meter from ground. 20 meter from the ground. So this is the answer. So they meet after 4 seconds and they meet at a height of 20 meter from the ground. All right, I hope Anirban, Randrali and Kamal Kumar, you have been satisfied. So if more problem and question, you can text me at this number, okay? All right, good night for today.